Good morning, afternoon, or evening, cats and dogs. Today's video will focus on the lesson 8.5 guided notes on solving equations with variables on each side. We are going to complete questions 1 through 22, including the summary box after questions 21 and 22. So first thing I want to talk about is some hints or strategies that I think you should follow when you are trying to solve problems that have the same variable on both sides of our equation. So the first thing I do suggest you do is add the opposite in the equation. This is going to help us make sure we don't miss any of our negatives, because if we have a subtraction, that's the same as adding a negative. If we go to simplify anything, which we will have to do on some of these problems, it's definitely a good idea to add the opposite first. The second step is to get the variables on the same side by adding or subtracting the variable expression on both sides. I suggest moving the smaller of the variable expressions, whichever of those two is smaller, since this will give us less negative numbers throughout the problem and throughout our work, and we know that when we have negative numbers, we tend to make more mistakes. Can you get the constants on the same side first instead of moving the variables? You can. The reason why I don't suggest doing that, the problem won't look the same as previous two-step equations. So I think if you move the variables first, basically after that one step, you end up with a two-step equation, which we're used to solving. Kind of like when we did two-step equations, you do your first step, and then that second step looks a lot like what you had seen when we did the one-step equations. The third step is, again, you've got a two-step equation at this point once you get the variables on the same side, and you solve it as we have already been doing, as we've been doing in this current unit. So you're going to notice mixed throughout some examples that are already typed up and completed for you. I'm not going to spend the time to go through those questions. We're going to go through the new questions, plus I'll mix in or intersperse some independent practice as well into our examples. So let's begin with question number 2. We have a plus 2 equals 5 plus 4a. So we have 1a on the left, 4a on the right. I do suggest moving the smaller variable expression. So I'm going to move the 1a. And I do that, since it's positive, by subtracting 1a from both sides. So I've got a 1a on the left, I subtract 1a, I subtract 1a on the right. Notice how I'm lining up my a's with my a's, my like terms. I've got a 1a minus 1a on the left, which leaves me with 2 equals, bring down my 5. My 4a minus 1a gives me 3a. So again, I've got 2 equals 5 plus 3a. You can line up these equal signs if you want as well. Now this is just a two-step equation. So our next step is going to be to subtract 5 from both sides. That's going to get us negative 3. 2 minus 5 is negative 3 equals 3a. Finish this by dividing both sides by 3. We get negative 1 equals a, or a equals negative 1. Now some of you might be thinking, how do we check our solutions for a problem like this? What I would do is replace a with negative 1 on each side. So do negative 1 plus 2. Negative 1 plus 2 is 1. On the right-hand side, do 5 plus 4 times negative 1. You can plug that into your calculators, but it'll also give you 1. Your goal is for the two sides of your equation to equal each other. They don't have to equal our solution, but they need to be equal to each other. All right, let's take a look at number 3. Now, number 3, be careful with this one. We've got 7y plus 25 equals 2y. I usually suggest moving the smaller variable expression, which in this case would be 2y. But I think it's easier if you subtract 7y from both sides so that you get a friend over with the 2y. You don't eliminate everything from one side of the equation. So in this problem, I suggest subtracting 7y from both sides. Now I'm going to show you an alternate way over here in just a moment. I'm going to show you a way that I see sometimes students do this problem that's incorrect. But again, you want that 2y not to be lonely on the right side by itself, so I suggest subtracting 7y from both sides. It's going to get us 25 equals 2y minus 7y is negative 5y. The inverse of multiplying by negative 5, it's a one-step equation, is to divide by negative 5. And your final solution is y equals negative 5. Now, I want to show you an incorrect way. This isn't in your notes, that I sometimes see students do this problem, is they subtract 2y from both sides. And they say, oh, 7y minus 2y is 5y, and they'll either write 5y plus 25 and divide both sides by 5 to get y equals 5. Notice how that's a different solution than we have over here. Or I sometimes see students who drop the plus sign here and they just move the 25 over to the right-hand side. They'll actually write 5y equals 25 here, which also is not correct because that 25 was on the same side as the 5y. You can't just move it to the other side without either adding or subtracting it. Now, I do want to show you another way you could do this problem. So, if I've got this and I want to subtract 2y from both sides, I can do that. So if I subtract 2y from both sides, that's going to get me 5y plus 25 equals 0. 2y minus 2y is 0. Then we would subtract 25 from both sides to get 5y equals negative 25, and then we would divide both sides by 5 to get y equals negative 5. So it can work this way. Just be really careful, because again, I'll have students subtract 2y, suddenly move the 25 over to the right and put the 5y on the left and solve it from there, and they'll get the opposite of what the correct solution is. So be really careful with that. All right, let's go ahead and take a look at numbers 4, 5, and 6. I will give you some independent practice, but if at any time you want to try some of these on your own, feel free to do so. So number 4, I have a 1n on the left and a 2n on the right. I would suggest moving the 1n. So it's a positive. I'm going to subtract 1n from both sides. That gets me 11 equals 1n. Now you could certainly divide both sides by 1, or just recognize that 1n is equivalent to or the same as n. So we get 11 equals n, or n equals 11. All right, number 5 is the first question that I do suggest you add the opposite since we have subtraction here. So I would write this as 7 plus negative 4c equals 3c plus negative 7. Now, we've got a negative 4c and a positive 3c. Negative 4c is smaller. It's a negative, so I'm going to add 4c to both sides. That leaves me with 7 on the left. 3c plus 4c is 7c. Bring down my plus negative 7. Make sure you keep each of these elements on the same side of the equation where they were. That's why we line everything up and we work down. Now, this is just a two-step equation. The inverse of adding negative 7 is to add a positive 7. So we get 14 equals 7c. We will then divide both sides by 7, and you get 2 equals c, or c equals 2. All right, let's go ahead and take a look at question number 6. Let's add the opposite here. We'll write this as 9d plus negative 9 equals 3d plus negative 3. We have a 9d and a 3d. 3d is smaller and it's positive, so I would subtract 3d from both sides. On the left, we have 9d minus 3d, which is 6d plus negative 9 equals negative 3. Now let's get rid of that plus negative 9, goodness. The inverse of that is to add a positive 9. So we get 6d equals 6. Let's finish this by dividing both sides by 6. And we get d equals 1 for our solution. So again, really all we're doing is one additional step, then we end up with a two-step equation. So pretty much from the two-step equation on, I'm going to move through those steps pretty quickly because we've seen those before. But don't be afraid to pause the video at any time if you fall behind. All right, let's go ahead and take a look at number 7. No need to add the opposite here. I've got a negative 2s and a 5s. Negative 2s is smaller. Since it's negative, I would add 2s to both sides. That's going to leave me with 3 equals 7s plus 24. Now it's just a two-step equation. Let's subtract 24 from both sides. We'll get negative 21 equals 7s. Divide both sides by 7. We get finally negative 3 equals s. So you're going to notice number 8 is already done for us. We're going to skip over that. We don't need to take the time to take a look at it. Now remember, there are other ways to do these problems, by the way. Again, you could move the numbers first. And in fact, in question number 7, I could have subtracted 5s from both sides first. You could still get the same solution. If you ever want to go through a different way of doing the problem that you think might be correct, feel free to stop in at office hours or check in with me at the end of class, and we can talk about it or take a look at it. All right, number 9. Let's add the opposite first. It's going to become 3b plus negative 1 equals 14 plus 2b. We've got a 3b and a 2b. 2b is smaller. It's positive. Let's subtract it from both sides. On the left-hand side, that's going to leave us with a 1b plus -1 and a 14 on the right-hand side. Let's add 1 to both sides. That gets me 1b, or just b, equals 15. If you get 1b equals 15, you can certainly divide by 1, but that's an extra step you don't necessarily need to do. All right, let's move forward and take a look at number 10. Now, I'm going to warn you, numbers 11 and 12 are pretty difficult, but I think as advanced students, it's a good idea to see some higher level questions as well. Before that, though, let's look at number 10. We've got a 12c and a 5c. 5c is smaller, so I'm going to move that. It's positive. I'm going to subtract 5c from both sides. That's going to get me 7c plus 18 equals 4. Now it's just a two-step equation. Let's subtract 18 from both sides to get 7c equals -14. Let's finish this by dividing both sides by 7. Our final solution will be c equals -2. All right, so these next two, like I said, are pretty challenging. I would start off by adding the opposite. So I actually did that in this. Whoa, goodness. I actually did that. That's going to keep doing that on us. I did that in this first step here. You're going to notice I added the opposite. You don't need to rewrite the equation again. We have 1/4 plus -2/3 y equals 3/4 plus -1/3 y. Now I have a -2/3 y and a -1/3 y. -2/3 is smaller, so I'm going to move that. So I'm going to add 2/3 y to both sides. That's going to leave me with 1/4 equals, and bear with me as it keeps moving that down, 1/4 equals 3/4 plus -1/3 plus 2/3 is 1/3 y. Now, let's subtract 3/4 from both sides. That's going to get us -1/2 equals 1/3 y. Now, bear with me here. Again, this line, ignore that. That just randomly showed up when I copied this in. We have -1/2, or -2/4, equals 1/3 y. We've got 1/3 times y. The inverse is to divide by 1/3 or multiply by 3. That will work as well. So we'll divide both sides by 1/3, and that is going to get us -1/2 equals y, or -3/2, or -1.5. Again, we're taking -1/2 divided by 1/3. All right, let's go ahead and take a look at one more. Again, don't be afraid to pause here if you need to jot that down. Another one with fractions. So in number 12, I'm going to add the opposite as my first step. So I'm going to rewrite 2 minus 1/8 n as 2 plus -1/8 n. Now, -1/8 n is smaller, so I'm going to get rid of that guy, and since it's negative, I'm going to add 1/8 n to both sides. So on the left, we want to use our calculators for sure. 3/4 plus 1/8 is going to get us 7/8 n plus 16 equals 2. Now let's subtract 16 from both sides. That's going to get us 7/8 n equals -14, 2 minus 16. Divide both sides by 7/8 or multiply by 8/7. That will get us n equals -16. So that one's not quite as bad as number 11, but they're pretty tricky. All right, let's try numbers 13 and 14, and then I believe I have a couple of independent practice problems for you. So number 13, I did start by writing the x's as -1x and 1x. Now I have a -1x and a positive 1x. -1x is smaller, it's negative, so I'm going to add 1x to both sides. That's going to get me 2 equals 2x plus -8. Now it's just a two-step equation. The inverse of adding -8 is to add a positive 8 to both sides. That's going to give me 10 equals 2x. Finish this by dividing both sides by 2. We get x equals 5. And I did make the numbers work out pretty nicely in all of these. You're going to notice a lot of whole numbers and integers, not a lot of fractional answers, although there will be a few. All right, in number 14, I'm going to add the opposite, make it 8 plus -1x equals 2x plus -1. I have a -1x and a 2x. -1x is smaller, it's negative. Let's add 1x to both sides. That's going to get us 8 equals 3x plus -1. Let's add 1 to both sides to get 9 equals 3x. And let's finish this by dividing both sides by 3 to get x equals 3 for our solution. All right. I know this is a lot of information here. Let's go ahead and give you some independent practice to try. All right. Give these 2 questions a try. Pause the video. When you're ready, restart it, and let's check those solutions. All right, I hope you've taken a look at both of these questions. Number 1, let's add the opposite first. Negative 2x is smaller, so let's add 2x to both sides to get 5 equals 10x plus 35. Subtract 35 from both sides. That is going to get us negative 30 equals 10x. Divide both sides by 10 to get x equals negative 3. Hopefully you got that. Remember, with all of these steps, one little mistake can throw off your entire solution or your entire answer. So please don't panic if you get more wrong than you're used to, because there's a lot more places where you can make mistakes. All right, number 2, let's start by adding the opposite. That 4q minus 15 becomes 4q plus negative 15. 4q is smaller, let's subtract it from both sides to get 9 plus 3q equals negative 15. Let's subtract 9 from both sides. That will get us 3q equals negative 24. Divide by 3, we will get q equals negative 8. All right, we have to mix some grouping symbols in too. Why not kick it up a notch? We are pre-algebra students. So number 15 is done for you. Let's take a look at number 16. We need to distribute first. So that means we're going to distribute this 2 into the parentheses and distribute this 5 into the parentheses. So let's do that. That's going to get us 2s plus 22 equals 5s plus 10. And now we solve it just like we just saw. So let's subtract 2s from both sides. That's going to get us 22 equals 3s plus 10. Now let's subtract 10 from both sides to get 12 equals 3s. We'll divide both sides by 3. That will get us a solution of 4. So again, just one step harder. But with every step, remember, that's an increased chance of making a mistake, so be careful. All right, question number 17. So I am going to distribute here. You're going to notice I added the opposite on the left. I wrote that as 7y plus negative 1. I distributed on the right here. So I did 2 times y to get 2y, 2 times 3 to get 6. And I also wrote minus 2 as plus a negative 2. Now at this point, I would combine like terms. So I would add 6 and negative 2 together before you try to solve. That's going to get us 7y plus negative 1 equals 2y plus 4. Now, it's just like what we saw at the beginning of this lesson. Let's subtract 2y from both sides. That's going to get us 5y plus negative 1 equals 4. The inverse of adding negative 1 is to add a positive 1. That's going to get us 5y equals 5. Divide both sides by 5. Our final solution will be y equals 1. Again, lots of steps here, so lots of places where you can make mistakes, so be really careful. All right, we have one last one that is hidden there at the bottom of the page, and I apologize you don't have a lot of space to show your work, but let's start by distributing. So I distribute this 2 into the parentheses, and notice how it says don't even think about adding 1 to 2 to start. It's really tempting to do 1 plus 2 since it's there, but we've got to distribute first. 2 times b is 2b, 2 times 6 is 12. In a moment, we will combine this 1 and 12 together. Distribute this 5 into the parentheses. That's going to get us 5b minus 5. And I'm going to add the opposite in a moment as well. So I wrote the left-hand side as 2b plus 13. The right-hand side, I added the opposite to rewrite it as 5b plus negative 5. 2b is smaller, so I'm going to subtract 2b from both sides. That's going to give me 13 equals 3b plus negative 5. Now we'll add 5 to both sides to get 18 equals 3b. And then we are going to divide both sides by 3 to get 6 equals b, or b equals 6. So lots of steps there, but we need to take our time. This is combining some of the skills from last unit with our current unit. All right, why don't you try one of these? Pause the video, give this problem a try. We'll take a look at it when you're ready. All right, I hope you've taken a look at this question. Let's go ahead and take a look at the work. Distribute this 5 into the parentheses. That's going to get you 10a plus 15. And then on the right-hand side, we have 4a plus 9. Move that 4a to the opposite side by subtracting it. That's going to get us 6a plus 15 equals 9. Subtract 15 from both sides to get 6a equals negative 6. Divide both sides by 6, and our final solution will be a equals negative 1. All right, we have one last topic to talk about, which is some weird equations. So let's take a look at number 19. So number 19, you're going to see that I distributed the 2 into the parentheses, and that got me 6d plus 14. And then 6d and 6d are both equivalent, so I subtract 6d from both sides, which cancels out the variable, and I end up being left with 14 equals 5. That statement isn't true. So what we say in cases like this, which will happen sometimes, we say that there is no solution. So you can either write out the words no solution, or we can use this symbol, which is essentially a 0 with a slash through it. So it means that there is no solution to this equation. In fact, there's no number that's going to make this equation true, which you might notice in this step. If we have 6d plus 14, we have 6d plus 5, they can never be equal to each other because the 6d's are equivalent. If you add 14 and you add 5, you're going to get something that's different. All right, let's try one of these. So in question number 20, we are going to distribute this 2 into the parentheses. So we are going to have 2x minus 2 equals 4 plus 2x. I did add the opposite though. Now let's subtract 2x from both sides, and we get negative 2 equals negative 2 equals 4, which is not true. Now you're going to notice I put the slash through the equal sign to indicate that those are not equal to each other. You don't need to have that. What you do need to state, though, is that there's no solution. So you either need to write the words no solution or do the 0 with a slash through it. So I know that you know that there is no possible solution to this. Now, sometimes I've had students ask, well, I did it differently, and I ended up getting, for example, 0 does not equal 6. Is that okay? Yeah. If you get a statement that is not true and the variable is canceled out, then it's a no solution kind of situation. I do want to mention that I sometimes see students get something like 6x equals 0, and they're like, there's no solution to that. Well, there is a solution to that. There is a number that when you multiply 6 by it, you get 0. It's x equals 0. You would divide both sides by 6, and 0 divided by 6 is 0. But again, I sometimes have students think, well, if I have 6x equals 0 or something equals 0, it has to be a no solution. That's not always true. All right, we have something else that happens, though. You might have been thinking, what happens if the solution or the numbers or the statement is true? The numbers are equal to each other? Let's see. In question number 21, I'm going to distribute this negative 2 into the parentheses after adding the opposite, just to make things a little easier. So negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. So on the left, I have negative 2x plus 2. On the right, I have 2 plus negative 2x when I add the opposite. You may even notice in this step that these two sides are equivalent. So they have to be true. But I could also add 2x to both sides to get a statement that is true. 2 equals 2. I've had students get 2x equals 2x. That's also always going to be true. So if you get something that's true, then the solution is all real numbers, or sometimes we just say all numbers. So any number that you plug in for x, whether it's a decimal, a fraction, a whole number, an integer, will make this equation true. So let's take a look at one of these. Question number 22. I'm going to distribute that 2 into the parentheses. So 2 times x is 2x. 2 times 2 is 4. I'm also going to add the opposite on both the right-hand side and the left. And I'm going to combine this negative 4 with this positive 3. So I end up getting 2x plus negative 1 equals 2x plus negative 1. Now, some of you could stop at this point by realizing that the two sides are equivalent. They always have to equal each other. But you can also subtract 2x from both sides to get negative 1 equals negative 1, which means that all numbers, or all real numbers, are solutions to this equation. So in summary, before we move on to some word problems, if you get a true statement, such as 5 equals 5, or x equals x, or 2x equals 2x, then the solution is all real numbers, meaning that any number will be a solution of the equation. If you get a false statement, such as -1 equals 2, or -6 equals 6, then the solution is no solution, meaning that no possible number will make the equation true. Not many equations will have either all real numbers or no solution as the answer. So if you get like every question being all real numbers or no solution, something probably isn't right. You might be overthinking it. So just realize that most questions are going to have a solution and not either an infinite number or no solution at all. All right, I know this video is getting pretty lengthy. Thanks for listening. We will, of course, do more practice of this in class as well.